Okay, let's start with the topic of the day, that is microservices in 2020. I hope you guys have heard the term. Maybe you have worked with a microservice, perhaps not. But to keep in balance, I will put it in a way that everybody can understand. And if you are new, you can get something. If you are intermediate, you can get something. Or if you are in advanced positions, you can take even more. But let's keep the balance and try to figure out what we can learn from this module. So I will be working with these topics as we go along. I will introduce what some monolithic is and why do we need to move it to microservices if you really need. And again, we will have to talk about container orchestration. And hello. Okay. Then we will talk about whether we want to move it to microservice or not. Okay, so little about me. I'm Randika Hapugoda, a technical lead. As you know, I'm a lecturer, also a blogger. So even before I tried this to teach you guys, I have taught this to my 1-year-old. So he seems to get it. I think you will also get the same. So he has no questions, but he understood. But I don't expect that level. I want you guys to take a note and come up with questions later on this after this presentation is over. Hit me with questions. Okay, let's start with the big thing, the monolithic application. So I think most probably you guys have worked with monolith for a project or maybe a research or something like that. You might don't know that is a monolith, but ultimately most of the time, 9% of the time, if you have worked in a application, it will be a monolithic application. So it's basics. You have a server. Let's say it is in Python, Java, Ruby, whatever language you like. You have a stack, maybe a web framework or something like that. And you have a couple of modules. In this scenario, I am using an e-commerce example. Maybe there is an account section, inventory section, shipping section, email and SMS module, whatever the API endpoints or modules that you have seen in application will be all bundled into one single application. Then you have a repository, maybe a database connection that you will use, maybe Mongo, MySQL, Postgres, whatever the database you like. You have a connection with this, and whatever you are getting from the API, maybe a post request to save something, you will get in your server. You just persist in the database and you are done. Whenever you want to read something, you just send a GET request, process it in here, and you will go and retrieve that data from the database, and you will go back to the mobile or browser. Pretty much this is the same application pattern that you have been using. If you have developed a sample or a simple application, maybe it is in production as well. So let's talk about what are the pros and cons in this architecture. It is, let's go with pros. Simple to develop, test and maintain. Of course, you can see most of you guys are familiar with this pattern. You know how to develop a layered architecture. Most probably you have seen a control layer, a service layer, a repository layer. These things are familiar to you guys. You guys have been working with these things. So it is simple to develop and also test and maintain, because there is not a lot of jargons around here, and a lot of resources can be found, and a lot of tutorials are based on this architecture, and easy to understand. You can see, as I mentioned here, the architecture has few layers, that is control layer, service layer, business layer, whatever the layers that you are calling is. It's very simple to understand. And visibility of application layers, of course, as I mentioned earlier, you can clearly see a cut. Okay, this is a control, and once the control handle this, it will go to the service layer, and once service layer is done with that, it will go to the repository layer or the database layer that we call. So the layers are pretty much visible in these applications. So it's easy to understand for even if you are an intern, maybe a junior guy who is developing a software application. It's very easy to find. And simple technology stack, yes. So you are using one programming language, one database most of the time, maybe two different languages, but it's very rare that you use two different databases in a single application or two different languages in a single monolithic application. It's very rare to find, but most of the time, for example, if I take a Node.js application, you would see an Express-based server, a Mongo-based database, then that's it. Perhaps if you are using a Spring Boot application, you will see, okay, this there's a Java-based Spring Boot framework. You will use Postgres, MySQL, or whatever the SQL database. Then that's over. That's the whole stack that you're going to be using. So that's a simple technology stack. Again, when it is come to deployment or when you are operating it, it's going to be pretty easy. So you're going to be taking a compiled version of your application, maybe where you want to put it into a single jar or in a Spring Boot context. You have a simple program that you can deploy very easily. You just have to copy it to a server or a host or wherever you are running this and simply just run it. You might have to configure the database in the production server. That's it. There is no jargon apart from that. Let's say about the cons about this application. The cons is it's tightly coupled. You can see that these modules, they are each and everyone is connecting via only this application. That means they are connected within these modules. So you can't, if you think that I would need to remove this accounting module, that would be a very hectic task because it might be depending on the inventory module or a shipping module that you have in this context. So if you remove the accounting, maybe shipping won't be working anymore. So that's the tightly coupled scenario that you have to address in a monolithic application. And in a large application, I have highlighted here this large application, the context is hard to understand. For in this scenario, we have like four sections or four modules in this application. But believe me, when it is coming to a production grade application, it is not the case. There are like thousands of modules, maybe hundreds of modules that are interconnected to each other. You need to go and find each and every module, what it does. Maybe they are calling a database, maybe they are calling external API, they are doing some sort of batch processing. So that's hard to understand at a grasp for a beginner when it is in a large project. Believe me, when I have seen a lot of guys who are struggling to even scope with this one section for weeks. So that's one con, that you have to understand the context in full to understand the whole application itself. And scalability issues. If you have seen or have developed some application and suddenly there is a peak on your application, you can't scale this anymore. You can't handle the user base that is connecting to this application. So what you have to do in a monolithic is, most of the time that I have seen is, you will duplicate this server. You will duplicate. I mean, you will have two instances of this application. Then what you will do is, instead of directly calling that, you will have a load balancer here. So what load balancer does it, whenever a request comes, since there are now more than one instance, it will try an algorithm and try to divide the work among those single instances. So in that way, you can you don't get the burden of single database. Single application. You will get multiple applications which will be handling multiple requests. So that's how monolithic most of the time is scaled. But this is not going to work. Most of the time, this is manual work. But if the load get overwhelmed, you can't do anything. And also, most of the time, what we are seeing here is they are all connecting to a single database. So even if the applications have reproduced itself, a database will be always a bottleneck because every instance they are connecting to the single database. So there is a performance issue in scalability and when it is coming to load balancing. So enter the era of microservices. So as you have seen in the last monolithic application that we have seen, we have accounting module, an inventory module, shipping module, email module, all in one. But now what we have is we have separate services, separate application for each. So in that manner, what you will get is truly divided sections, truly divided or individual sections that you have to be that is working individual of the main application. They are not tightly coupled in this scenario. They are not tightly coupled. So as I mentioned earlier, this is tightly coupled, but how come this one is not tightly coupled? Well, that's something we have to address. Okay, microservice is you can't have, like, we have a monolithic, let's move it to microservices. We can have each module in a separate service. That won't work. So microservices, there are some patterns that we need to have to separate these modules into what they are. I will talk about the patterns in a later bit, but for now, remember, there is another good thing that we can see here is the accounting module is using a database, let's say database X, and inventory module is using another database, that is database Y. So in this scenario, you can see that you don't have, in this XY scenario, I have differentiated the two databases types. Say for instance, X is equal to MongoDB and Y is equal to Postgres. So in this scenario, in the inventory module is using Postgres database. Accounting module is using a MongoDB database. So that's the advantages. So we in a monolithic application, we were stuck to a one database type, but in a microservice architecture, you are completely depend on these modules. You are completely separated. Now you can use whatever the database you are comfortable with. Most of the time, it's not all about comfortability, but it is also about the best use. As you know, the MongoDB, let's say it's a document database, it's good for reads. Okay, so we can, if the account module is getting too many reads, you can use MongoDB. And let's say SQL database, they are good known for their writes. So we can use inventory module like inventory module to have so many writes, then we can use Postgres. You can optimize your scenario using the suitable database that you like. I mean, use your database wisely when you are developing your microservice. So you can have polyglot data sources. When we are using so many databases in one single application, we call this polyglot data sources. So that's one advantage of using microservices. So earlier there was one single application. So every API request or every request that comes in, it will automatically decided by the application itself or the control layer that we had in our application. They will route this request to the service or whatever the underlying layer that we had. But now, since we have things separated with each other, what we have to do is we have to introduce a new section or new component into our architecture called the API gateway. What API gateway does is, let's say we are requesting an account detail. Okay, so the request come to the API gateway first, then the API gateway is smart enough. Okay, this is a request for the account section. So API gateway will redirect that request to the account module that we have. And whatever the things that you need in the database, it will go back here. So it won't touch even these things if there is no interconnection between these things. So the API gateway is like a router. We call it sometimes a reverse proxy that handle all the requests. Whatever the need they have, they will call the relevant service and get back to the customer. Okay, so this is new. I will talk about this in a later bit, but try to understand the context or the problem that caused by the microservices, how to communicate with these services. API gateway will help you that or routing this request. So this is same as monolithic, right? Only thing is these are in several or separated application. But now remember, this process can be expanded into scalable application. I will walk you through how we can do that. So let's talk about pros and cons of microservice architecture as I explained here. So it is decoupled. You can see this service is totally independent of this service. Okay, I will explain how we can achieve the decoupling in a bit. And it is scalable. How do we know this is scalable? Well, that is pretty easy. What you have to do, let's say our application is having a lot of requests to inventory module. Let's say inventory module is the most used part in our application. So we can individually scale this inventory module, okay, without scaling this, without scaling other modules. We can individually scale the inventory module. But in a monolithic application, you don't have that option. You have to, if you are scaling up, if you are load balancing, you have to scale all of this application because they are tightly coupled. You can't scale only one. But now, since these are loosely coupled or decoupled with each other, you can individually scale this inventory module. Let's say inventory module have 3 clones. So we have inventory module 1, 2, 3. So API gateway will know if a request come into inventory module, API gateway will automatically load balance between the 3 inventory modules. But the account module is not getting that load, so there will be only one accounting module. Okay, so we can individually scale this application, whatever suits for our application or whatever the most request or most data is coming or most use module, we can scale that individually. So that is one big advantage of microservices. We can individually scale the applications. And easy to understand the context. What do you mean by easy to understand context? In a microservice architecture, remember one module, most of the time it is developed by set of engineers, one BA and few test and QA guys. Okay, so the account module is responsible of a smaller team. So the context is small for the team. Okay, they are not always gonna go into inventory module and try to figure out the inventory module themselves. Okay, there's a small team of people who are really brilliant at accounting section. They're going to be developing this, so their scope is very low when it is coming to the whole application. So if you are a new guy, you just have to figure out the accounting module yourself. You don't have to worry about any other things unless you have to communicate with these. There is interaction between these things, but it's going to be a something like a basic REST request or a GRP request or RPC request. You just need to know how to communicate with this thing. You don't need to what the mechanism underlying or whatever the things that's going on uh, this service. Okay, you just need to know your context where you will be using these things. Okay, so then again, there is polyglot data sources, as I mentioned earlier. You are not bounded to one database. You have several database types, or whatever the database suits, you can use it in here. And you can see it is better organized since these are decoupled. You can use these things in a manner that that you can clearly cut the service layers, and you can work with these things pretty much easily. So the cons. So if it is that good, why don't we do everything in microservice? So there is a few concerns when it is coming to microservice. That is, the operation cost is high. Earlier, there was only one big service that we have to manage. Now we have to manage few services, and not to mention there are added services like this API gateway. So we have to have API gateway now. We have to have separate servers or maybe instances. Ultimately, this will increase whatever the resources that you are having. It will be increased. There will be several database types. It will be increased. So operation cost is a little bit higher than we can expect from a monolithic application. And yes, there are architectural patterns when it is coming to microservices. It's like it's not like in a monolithic application there is 3 layers or n-layer architecture and you are done. No, microservice has so many different patterns that you have to come across to design something like this, to architect something like this. This is like 1,000 feet up view of a microservice, but when we drill down to these individual services, it's not going to be that easy. It's we have to design a pattern how to communicate with these things, how to connect these things, how to separate these things, and how to separate databases. These are the patterns that we have to follow of the rules that the people have found will best suit for doing a microservice. So as I mentioned earlier, there are patterns in a microservice that we need to follow. So what are these patterns? Most of the patterns come across under these few categories. Okay, as I mentioned earlier, there are decomposition patterns. Decomposition patterns involves if you have a monolithic application or you are trying to design a new microservice, you need to have a good understanding how these individual components going to be decomposed. Are they based on logic? Are they based on subdomain? Are these based on business logic? You need to have a good understanding how do we differentiate these modules, what things goes in here, what thing goes in inventory module, what thing goes in accounting module. You need to have a decomposition pattern to figure out how these things are going to be moduled. So that's the decomposition patterns that you will have to learn. I'm not going to go into deep into these things out of this context, but I will give you reference and pointers where you can understand this decomposition pattern and apply in your real life applications. And the integration patterns involve how do you communicate with these modules. Let's say you have accounting module. How do these API gateway incorporate in here? How do this accounting module will communicate with this inventory module if they really have to? I mean, that's kind of things. How do we integrate each of these services? How are we going to do that? It is covered under this integration patterns. So there are a few patterns that you can use, but it's going to be not covered in this scenario. I will leave reference so you can have a look and come across any problems. You can actually contact me. So there are database patterns. Okay, so we have seen that each service have one database. Okay, as I mentioned earlier, I can scale this inventory module into 3 sections. I can have 3 clone of this inventory module. Then again, there is a pattern emerge whether that this inventory module, as you can see here, will be using another database. And let's say this is also the second inventory module, whether it's going to use this database or it's going to have its own. We are calling that a database pattern. We have to make the decision whether this inventory module is using whether 2 or 3 inventory modules are going to be sharing same database or are they going to have their own database. So those are the decisions that we have to make when we are overcoming a database pattern. So these things, whenever you are coming into microservices as like me, those things are very hectic things to decide. We don't know whether we need this or not. So there are things to concern. If your business requirement matches whatever the pattern described, then you are good to go. Use those things. So you can understand a few database patterns over there. Then you can decide, okay, to our business requirement, this database pattern is going to be the most suitable one. And there is observability patterns that's basically going to be working with something like we have accounting modules generating logs, inventory module is generating logs. So we have to have a way whether these things are interacting or we can observe these things are working. Let's say, for instance, for no reason accounting module goes down. How do we know that accounting module is going down or whether it is working or not? So those kind of things can come under observability pattern. Okay, you have to have a way to recognize whether the service is down. If the service is down, how can we overcome that? How can we, without breaking the whole system, how can we recover from that? Those all are covered in observability patterns. And then again, the next thing is cross-cutting concern patterns. That's involving. You can see that we have introduced an API gateway here. Okay, the API gateway is something new for us, but there are few other things that along the way you will see that we need here in this microservice whole architecture to operate these microservices. So for brief concern, I will I will go few patterns that we are been using in a microservice. Those are these cross-cutting concern patterns. So I will be explaining a few things in here. So when you are starting a microservices, actually this cross-cutting concerns is play a major role. So I will explain it here as we go along. So you have seen the API gateway, of course. Now you know what it does. It's like a router. Whenever a request comes, he will be responsible whether this should be going to this microservice. This request should go into this microservices. Likewise, API gateway is responsible for that. Apart from that, there are few patterns that you will find that most of the time the security. If you are saying, okay, you can't access this microservice, the API gateway does it for you. So you have a security layer on top of my API gateway. So without going into deeper levels of your services, the gateway will restrict, okay, you have access to this module or you don't have access to this module. So API gateway play a router, sometimes a security layer or auth layer, let's say. So we can configure the API gateway likewise. So there are software, so predefined software that you can use, of course, right out of the box. If you are trying to develop a microservice, you don't have to reinvent the wheel. The most popular ones that you will see, most popular softwares out there will be Spring Cloud Gateway, of course, the Netflix Zool. The Netflix Zool is one of the most old API gateway. If you are coming from a microservice, if you have done something, you might already know Netflix Zool. But if you are not familiar with Zool, my recommendation is go to with Spring Cloud Gateway if you are using now. But you are not bounded any of these. You can use API Manager from WSO2, AWS API Manager, the Kong Gateway. There are so many options you can have. But remember, when you are choosing whatever you like, be sure to read the documentation they have and try to figure out whether this API gateway is suitable for your business logic or your microservice. Always read the documentation. Otherwise, in the middle, you will find, okay, the Netflix tool doesn't have, for example, I have come across this. The Netflix tool first version didn't have support for WebSocket. So whenever we want to implement a WebSocket, Netflix Zool won't do the thing. So we have to wait until Netflix Zool to come out. So those kind of things are there. Be careful what you're choosing, but always you have to read the documentation and get away with, you can get more information on that. And again, there is another pattern evolve that we need to resolve. So as I mentioned earlier, you can have 3 inventory modules. Okay, you have one inventory module, let's say inventory 1, inventory 2, inventory 3. That's going to be the same inventory module. These going to be clones, not going to be individual things. These can be clones. So There are three inventory services that can process inventory request, but how do we know that? How do the API gateway knows that there are three of these are available? You can't uh, you can't manually do those things. Okay, in monolithic application, of course, you will hard code your inventory module's IP address or the whole application IP address to the load balancer. But in a in a in a scenario in a microservices, we don't have anything saying, okay, we have three inventory modules, we have two shipping modules. We don't know. It will be depend on this. It will depend on the request load, or it can be configured to scale automatically. We don't know how many inventory modules if going to be there if you auto scale these things. Let's say if peak comes, we say, okay, have 100 inventory modules. We don't know the IP address of these things, where those are deployed. We don't know. So what we have to do is we have to have the API gateway need to know how many inventory modules are there and what are those IP addresses. So API gateway can load balance these things with the inventory modules that we have cloned right now. So we need to know the registries we know to know what are the services. So the services need a registry. Okay, we have a service registry, another piece of software that will come in place. What it will do is, whenever a application is spinning up its own clone, it will go and register in the service registry. Okay, let's say we have a accounting module, we are scaling up it to another module. What we'll do is, once this is spin up, it will go and register in the service registry. When this one, the second clone is spin up, it will go and register in the service registry. The API gateway will get a contact with the service registry, and he will get updates. Okay, now there are two accounting modules that available. API gateway will, once the new request come in, the API gateway will load balance between these two newly created modules. Okay, the service registry is the place every service that get registered. Okay, I am here. This shipping module is going to say I'm here. Email SMS module going to go here and say I'm here. The API gateway knows, these services are available. Now I can communicate with these things. So the service registry page play a major role in a microservices when it is coming to scaling. Okay, so remember, like not like a load balancer, these things scale automatically. These things scale down automatically. So what we have to do is we have to know what are the things available, what are the services available, and how many instances are there. So service registry is like a database connecting the location of the service instances. They know where the services are, what are their IP addresses are, so they can communicate the API gateway. Okay, there are so many instances of this service. Use this when you're having too many load. So, for example of service registry, you have etcd, one of Kubernetes sections right now. Uh, a, a good service registry that you will find in Orchestration even. And for the old era, you have Netflix Eureka, one of the most old softwares, but even up till today, it is working perfectly. So you can use that. Then you have Console, that is acting as a service registry, which is from HashiCorp, and Apache Zookeeper. You can have a service registry with Apache Zookeeper as well. So these, if you configure these softwares, you can have a service registry in no time. Okay, there are few commands that you can up and running either one of these service registry. You have to use one. So if you are in 2020, my recommendation is not to go with Netflix Eureka right now, because it was like in old days. For updated one, use Console or etcd for better things, or for the new technologies. If you are using, go with one of either of these things. So we have identified one thing, that is service. How do we know service exists or not? we can use the service registry pattern, then that problem is gone. Okay, but in microservice architecture, that's not going to be your only problem that you are getting at this point. Okay, for example, let's say we have this accounting model using let's say a database connection or a API key for some third party integration. Let's say accounting model connect with Google APIs. Now the Google API have expired their key. You need to use a new API key in this accounting module. So if it is in a monolithic application, what you will do is you will go to the source code, change the API key, and compile it and deploy it in the deploy it ever what you like. But in microservice architecture, this architecture is designed to have a resilient application. You won't stop your application to update a configuration or update. It will run 24/7. So you can't expect to change a key in here to shut down all of these services and spin up. So what you can do is, whenever you want to change a configuration over here, let's say even another case is like we have like we can go into this and change only this instance API key. But think in a scenario where you have like 10 or 20 of account modules instance are there. So what you're going to do, you're going to go in each of these instance and change the API key. That's not possible. If you're having thousands of instance that is running in a large scale application, you can't go to one okay, change the API key here, change the API key here. Likewise, it's not possible. So what you can do is we can have the configuration of these each and every application in an external configuration section. So external configuration section is something like this. Okay, you have accounting module. All of your configuration about this server is in a configuration server outside of this scope. Okay, so you go whenever you want to spin up a accounting module, first you go to the configuration server, fetch the configuration, then come here. It will spin up with this configuration. Okay, this configuration server may have the database URL, whatever, the port number that you need to write, run, everything that is related to the configuration over here. It will go and fetch from the configuration server, come back, and it will spin up one and go to the service register and say okay, I am ready. I can now take requests from API gateway or whatever. The second modules comes in, it's go to the configuration server, fetch the configuration, come back, spin up, and go to the service register. Okay, I am ready also. For example, now we want to change the configuration. Let's say we want to change the Google API key, but apart from going each and every section of the account module, the configuration servers knows, okay, there is an accounting module registered in the service registry. If the configuration server say, okay, I need to change the accounting modules Google API key, you do it here. Okay, the service, the key need to be changed, you do it in the configuration server. The configuration server is responsible for communicating that each and every account module that they have spin up. Okay, so you don't have to go to each of these instances. You can say configuration server, change this in all the instances that is available. The configuration server does it for you. Okay, those are the basics things that you can do to without stopping your application. Largely scale application, you can just change here, everything get reflected over here. Okay, the service registry is there once these configurations are done and once they are registered. So each and every instance or each and every services have their configuration in a configuration server like this. So every time a shipping modules goes, want to instant a new service, it will go to the configuration server, fetch the configuration, come here, spin up the application, register in the service registry. So configuration servers are really easy to find. There are things like Spring Config Server, which is a very convenient way of or very easy way of doing configuration management. Of course, there is console, Apache Zookeeper. As you can remember, console act as a service registry as well, also the Zookeeper. So you get two birds from one stone. Okay, if you use console, you get external configuration server as well as a service discovery layer. So you don't have to spin up two instances of console or two different sections. Like if you want to use a config server and a service discovery, both of these will satisfy by the console or Zookeeper. So that's an advantage if you are using the software itself. Otherwise, you have to use a different configuration server and a different service registry, which will know how to communicate and will fit in this microservice architecture. Okay, the next big thing is how do we deploy these things? Okay, as I mentioned here, in a monolithic, it is very simple. You will compile or you will have a binary that can run on a AWS or a hosted server. You just copy those things, it will work. But not in microservices. Microservices, you have to orchestrate everything. You have to uh, figure out how these things going to be layered off or how these things going to be running on. So most of the time, these things are handled by Docker. Okay, the container so much popular in these days is it's going to be Docker. So you can use something like Docker to orchestrate, or uh, you can deploy. Let's say we have this accounting module written in Java. You can have this service wrapped in a Docker container and tell Docker to spin up two instances. So that's easy when it is coming to the orchestration with Docker. So 99% of microservices that I have seen so far, they are using Docker as the container solution. Then they will deploy these instance using let's say Docker containers. Okay, so we create a Docker image using this module, and if you want two instances, we tell Docker, okay, run two containers from this account module. So basically, if you don't know Docker, you should get insight of Docker, how it is doing, what's the difference between Docker and a VM. Those sort of things you have to figure out yourself if you are new to in this section. But ultimately, you will find it is very easy. There are like simple commands that you need to learn. Okay, and also you need to know how to wrap your microservice. Let's say this is a Node.js application or this is a Java application. How to wrap this in a Docker image. Okay, you need to package it into a Docker image, then run. So the next big thing is orchestration tools. What do you mean by orchestration tools? The Docker images, they are fine, they are working, but when it is coming to handling the containers, we need way to handle the containers. Let's, for instance, we have this accounting module, and we want to keep always at least two accounting modules running in our application or running in our microservice. No matter what, the account section is getting too much request. So every time there should be two accounting modules. Okay. So as a developer or a DevOps, you can't watch these things. You don't know whenever the service is going to down. You can't say, hey, the service down, now I need this account module is not working as expected. We need two accounting modules running all the time. So you can't do that. So the help of orchestration tool, you can do that. Okay. So let's say you have so many options that is available to orchestrate our containers. That is it's think orchestration tool is like a caretaker for our containers. Okay. There are so many options available, but these highlighted ones, these things you can even deploy in your local machine and try it yourself. I would recommend to go with Kubernetes. It's it's like a free and open source version. It's actually free and open source, which from Google. So if you are using Kubernetes, you can have a small microservices running in a Kubernetes cluster. Okay, so if you are using Kubernetes, that will be a good point. But uh, teaching you Kubernetes is out of this scope. It is another course for another day. But have a look at Kubernetes so you know how to deploy a microservice in your context. It's not going to be the same as a monolithic. You need to have a container orchestration tool as a first priority if you are developing a microservice. So Kubernetes have a local version called Minikubes. There is OpenShift. OpenShift is also based on Kubernetes. So underlying OpenShift, they are using Kubernetes as Google Container Engine is also using Kubernetes. So this is like a godfather to you. You can use Kubernetes from the beginning and try to understand. But I recommend OpenShift if you have time. Go with OpenShift. It's making things easy. Let's say we have Kubernetes cluster open. We have account module in a Docker image. Now what we can say is, hey Kubernetes, always run 4 instance of account module. Whatever happens, if until Kubernetes runs, there will be 4 containers running all the time, no matter how many network requests get down, how many faults get down. If Kubernetes is running, your microservice architecture will survive that. Not only that, the replication control, it's not going to be replication controller alone. Kubernetes has so many features. There are like 12 to 13 features available built in to Kubernetes, which will help you to develop a microservice or deploy a microservice on top of Kubernetes. That will help you to, like, as I mentioned earlier, service replication, secret management, pod networking. Like, there are so many things that you need to learn in this context. But remember why I am putting all these jargons in here. If you are developing a microservice or if you are trying to move your monolithic into microservices, you should know where your deployment strategy is going to be. You should know how you're going to develop. You can't develop a microservice. Okay, now the microservice is done. We have developed all the things. Now we have to figure out a way to run. That's not going to be the case. You, from the beginning of your project, you have to decide what is the orchestration tool and how we going to deploy from the beginning of your project. Otherwise you will get developing a nice microservices, but you don't know how to deploy that, then you will be in trouble. So from the first day, get a container orchestration tool. If you are not familiar with it, master it, then play around with the microservice itself. Okay, there are so many options available. Try one of these things. My recommendation is go with Docker Kubernetes. There is Kubernetes. There is Docker Swarm available, but that's not in use. We have to go with the trends. So trend is going towards Kubernetes. Try it. It's really it's a bit complicated at first, but when you know the things, hey, ultimately you know things. Okay, the next topic is okay, if this is the best solution, or if we're gonna developing application in 2020, no monolithics, we're gonna go for the microservices no matter what. We will learn microservices. No more monolithic. Bye bye monolithic. We are not using you anymore. We have new kid in the block. We are using microservices. That's not gonna be the thing. Okay, you have to understand where to use microservices and where to not. Okay, so you have to know the limitation of your team, you know the limitation of your client, know the limitation of requirements that you are getting, and decide whether to go to microservice or not. You need to have a better understanding of the patterns in microservices. You need to understand the team capacity. You need to understand the client requirement as well. Okay, the most of the time client comes, okay, we need this in microservice, let's do it in microservices. But ultimately there will be like 2 or 3 users who are using the website in a daily basis. You don't need a microservice over there. You should say the hype is microservice. Of course, Yes, but you don't need in your context, you don't need a microservices because it's gonna make things worse. Okay, you need a monolithic. You will survive with a monolithic. You should understand and explain the situation to the client. Don't go with the jargons. Always stick to the basic. And client uh, client might say, okay, we need this, but you have to be conveying, okay, we don't need this, we can go with the monolith. So remember, microservice won't solve all of your problems. Heck, it will make things worse. Believe me, moving from a monolithic to microservices is a hectic task. You should know everything that you, not everything per se, but every encounter part that will come across when you are using a microservice architecture. You have to be prepared to address any of these problems. It will make thing a little bit complicated, so you have to be prepared to address those things as well. So I'm not discouraging you, but my suggestion is always do your research first, then try to develop a microservice. Don't just go in and there and try to develop software, the next solution, without diving into microservice patterns and architectures and everything. You have to do a good research, then try to uh, develop your own microservice. So where to start? So if you are new, this is the best place that you can see. If you are intermediate, you might miss these things. You can figure this out, or you can read these things out and try to start developing a microservices. So first thing is, you need to know the fundamental theories. All the things, I know theories are really little bit hard to read. If you are a hard coder, then you will say, okay, we don't need the theories, we can do it from scratch. It's there going to be several services who we can work, but not in this case. Believe me, even the best get stuck. So always go with the basics. Go to microservice.io. Fundamental theories are there, you can read from there. And if you are new to Docker, please try Docker first. Otherwise, you will get stuck in the process of deployment or orchestrating your microservice. So get these things done first. Then, if you are confident enough, you know most of the things from here, move to a project like Spring Cloud. You will see how many projects under Spring Cloud is there. Okay, there, as I mentioned earlier, there are a few umbrella projects that I have mentioned, like Spring Cloud Config, Spring what do you call config server, service registry. There are a lot of projects under this umbrella, which you will find very useful. At least know what these products are doing. Okay, what is the pattern they are trying to solve? What is the help that we'll get from Spring Cloud's ecosystem, or this is an umbrella project you can use. There are so many projects under this, so you have to know at least what they are capable of, what they are trying to solve. And if you are really into coding, I would recommend this Cloud Native in 1 hour, which will develop a simple solution or simple microservice within an hour. But you should know about some containers and how to write Spring Boot applications and all those stuff. But it's pretty much easy. You will see the power of Spring Cloud and microservices that you will find in this 1 hour lecture or 1 hour tutorial. There are other patterns that have been using here, like the circuit breaker pattern. It will be used here, but of course the discovery server and all those things going to be here. There's another pattern called circuit breaker pattern, which will be discussed in this 1 hour course. And if you want to really into Kubernetes and stuff, go to Kubernetes basics and learn these things. It is really helpful when you are trying to get into DevOps or something like that. These days, people are looking for people who are looking into DevOps. Of course, you need to have Kubernetes knowledge. So have a look at this Kubernetes basics, then move on. So at least these things should be covered for an intermediate person. And if you are really, really genius and you have done so many things, now we want to know the advanced stuff, go to these two topics. The first one is DDD and CQRS, a really interesting way of modeling your application and how to connect with databases that you have seen. It's completely new. Actually, it's a all theory now, each match in a microservice context, uh, very in a very good manner, that you can see how these things get together in microservices is really helpful. Uh, the decomposition pattern that we will see is domain driven design here, and the CQRS, command query resource segregation, which will help you to have a different perspective, a different way of coding per se in microservice architecture. Of course, you can use this in a monolith as well, but it's a match made in heaven with microservices. Again, you might have used REST APIs, but in microservice context, it is not that case. Sometimes you want to use a more optimized way of communicating with each microservice and all the stuff. You will probably end up using gRPC, the RPC protocol from Google. So these things, as I heard, Google are using internally with their microservice solutions or internal communication per se. So really dig into these things if you are advanced person who is looking for your next career in microservice or whatever you are doing. You should really go into this, but remember, going this way, not the other way, you will get stuck. Okay. Right. You can always contact me if you have any concerns or regarding the lectures or microservice or even help monolithic, whatever you like. If I know, I can help you guys in any way. Uh, you can contact me either way. Most of the time, WhatsApp me on this number. I am actively using WhatsApp because it's easy. And thank you for listening for a whole lot of jargons if you are new here. But I hope you got something out of this session. Maybe you will start something. Maybe you have found something new. In 2020, there are things evolving so rapidly in this era. Things are moving too fast, so you have to adapt it. Otherwise, you will lose things. If you are if you are using Netflix stack in 2020, you are gonna be in great danger. Okay, you have to update yourself to the next level. There are so many things like Istio, Kubernetes, a lot of things to learn. So you have to update yourself in 2020. Okay, that's it for me. Thank you. Let's take any question if you have. Oh,
Hi, Randika. I have a question.
yeah, go ahead with it.
So, when it comes to version controlling, what do you recommend in a microservice architecture? If we have APIs with several versions,
Yeah.
what kind of thing that we can do for version controlling?
Yeah, if you are API version controlling, then my recommendation would be not to have a separate version of a microservice there. Okay, now the API versioning is going with e-tags. If you have heard the e-tag headers that you can find in your REST API calls, that's not per se in a microservice architecture. You can use it in a monolithic as well. Best solution would be go to e-tags, where you have a version where you have say, let's say API version 1, then you have the e-tag along with that, so you will get redirect to that. You can actually program your API gateway even yourself. Let's say as I mentioned earlier in these where do I get that? Okay, yeah, here in API gateway, you can have a rule. Let's say accounting, this is accounting service version 1, and this is accounting service version 2. Okay, this is API version 1, this is API version 2. You can have this API gateway configured, pre-configured Okay, anything comes to version 1, go to this microservice. Anything comes under version 2, go to this microservices. So you have the capability on API gateway, or you can use etext. That answers your question?
Yeah, got it.
Okay.
Got it.
Okay then. See you guys.